at the midpoint of the line joining the two charges, that is V equals V naught difference VD, the point of intersection of the two diagonals. E is nothing but V divided by D, electric intensity. Hello students, this is SD Sir, yet again for you all from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. The last two sessions I have been solving numericals from the concept of capacitors. Hope all of you have practiced that. You are thorough with the expressions, topics, formulas. In my today's session, I will be discussing simple problems from the topic of potential. So let us start solving the problems from the potential chapter. The first problem, students, the problem says two tiny spheres. There are two tiny spheres, small spheres carrying charges plus 1.5 microcoulomb and plus 2.5 microcoulomb respectively. So I have two tiny spheres which carry charges 1.5 microcoulomb and plus 2.5 microcoulomb respectively, and they are 30 centimeter apart. The distance between the charges is 30 centimeter. Find the electric field and electric potential. In this particular chapter, in this particular problem, I will reframe calculating only the electric potential at the midpoint of the line joining the two charges. So I will be calculating only the electric potential at the midpoint of the line joining the two charges. Now, to pick the data, Q1 is plus 1.5 into 10 power minus 6 coulomb. Micronallide 10 power minus 6. Q2 is plus 2.5 into 10 power minus 6 coulomb. And the distance of separation is 30 centimeter which is 0.3 meter. What am I to calculate? Electric potential, where midpoint of the line joining the two charges. Now, we will construct the diagram here. So this is the first charge Q1, the second charge Q2. How much is Q1 given to be? 1.5. So this is plus 1.5 microcoulomb. Q2 is given to be plus 2.5 microcoulomb. Now, they are separated by a distance of 0.3 meter in air. What am I to calculate? Electric potential at the midpoint of the line joining the two charges. Now, I call this as A, I call this as B. Q1 is placed at the point A, Q2 is placed at the point B. Now, first I will calculate potential at P due to the charge Q1. So, electric potential at P due to the charge Q1. Come on, students, recall the expression for potential. Intensity Allah. It is simply potential. So V1 1 by 4 pi epsilon naught Q1 by R1. If it was intensity, R square. This is only potential. So Q1 by R1. So on substitution, V1 is 1 by 4 pi epsilon naught. Q1 is 1.5 into 10 power minus 6. What is R1? Distance between A and P. How much it is? 0.15. Because very clearly the problem says P is the midpoint. It is the midpoint of the line joining the two charges. So this is 0.15. Next, potential at P due to the charge at B. So, electric potential at P due to Q2. The same formula. So, V2 is equal to 1 by 4 pi epsilon naught 2.5 into 10 power minus 6. Again, 0 point. Now we know that electric potential is a scalar, which means V is equal to V1 plus V2 or V1 plus V2 on substitution. What is the value of 1 by 4 pi epsilon naught? It is 9 into 10 power 9, which is common. On simplification, V turns out to be 2.4 into 10 power 5 volts. So using one simple formula, I have arrived at the potential at the point P. The next one, students. This is a very, very important problem. This is often asked for 5 marks in the examination. You have to learn thoroughly to solve this. Point charges plus 2 nanocoulomb plus 4 nanocoulomb and plus 8 nanocoulomb are placed at the corners A, B and C respectively of a square. Very important. The problem says it is a square of side 0.2 meter. So according to the problem, there is a square A, B, C, D. Problem prakara ಏನನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ? ಒಂದು ಸ್ಕ್ವೇರ್ ಇದೆ. What is the side of the square? Analyze the problem. 0.2 meter. So this is 0.2 meter. What is the charge placed at A? Plus 2 nanocoulomb. Charge placed at B? Plus 4 nanocoulomb. Plus 4 nanocoulomb. Charge placed at C? Plus 8 nanocoulomb. I have to calculate the work required, work done to move or transfer a charge of 2 nanocoulomb from D to the center of the square. Andre, there is a charge of 2 nanocoulomb at D, which has to be moved to the center of the square. Charge of 2 nanocoulomb has to be transferred from D to the center of the square. I require some work, and that work has to be calculated. Now, what is the center of the square? We know it is the point of intersection of the two diagonals. Alba? It is nothing but the point of intersection of the two diagonals. Andre, my first objective here is to calculate the distance OA, OB, OC and OD. How do I do that? Now, from right angle triangle, I consider BDC. So BDC. I am just applying Pythagoras theorem. BDC, from which BD square equals DC square plus BC square, which is 0.2 whole square plus 0.2 whole square. Calculate BD. So once you calculate BD, OB should be half of that. Alva, calculation parts for y'all. Just I've given you the hint. The simplification has to be done. Which means from the diagram, OA equals OB equals OC is equal to 0.1 root 2 meters. See, simple. Apply Pythagoras theorem, calculate the hypotenuse BD. OB should be half of that, which is nothing but OA, OC and OD. On simplification, it is 0.1 root 2. To begin with, I will calculate total potential at O. I am calculating the total potential at O, which will be the sum of potential due to charge at A plus charge at B plus charge at C is charge at D coming into picture when you calculate potential at O. No. Why? I am moving the charge from D to O, so it doesn't contribute. So here, V naught 1 by 4 pi epsilon naught is common. This is QA by OA plus QB OB QC by OC. So V naught is 9 into 10 power 9 because 1 by 4 pi epsilon naught. QA is 2 nanocoulomb. So 2 into 10 power minus 9. OA is 0.1 root 2 plus 4 into 10 power minus 9, 0.1 root 2 plus 8 into 10 power minus 9, 0.1 root 2. 10 power plus 9, 10 power minus 9 cancels. 0.1 root 2 is common. So on substitution, V naught turns out to be 891.1 volts, or roughly 891 volts. Now similarly, I will calculate the total potential at this point D. Potential at the point D. Again, sum of potential due to charge at A, due to charge at B, due to charge at C. So this is 1 by 4 pi epsilon naught QA. Now observe carefully. The distance is AD. Potential at D due to the charge at A, AD. So this is AD plus QB divided by BD plus QC divided by CD. Again substitute 9 into 10 power 9. Again QA 2 into 10 power minus 9. Now AD is the side of the square, 0.2. Now this BD, be very careful, is the hypotenuse whatever you have calculated. Be very careful on substitution here. BD is the hypotenuse. I just write as it is because you have already calculated before. Plus 8. Again CD 0.2, which turns out to be 577 volts. So I have calculated the potential at A. I have calculated the potential at D. Now I will calculate the potential difference, that is V equals V naught difference VD. 871 minus 577, which is nearly equal to 314 volts. So this is the potential difference. But what is that I have to calculate? Work done. Now by definition, potential is W by Q. So W is V into Q. V is 314, 9. So this is around 628 microjoule. So this will be the answer. Appears to be tedious, but you know the concepts, proper substitution, easily you are landing at the answer. The next one, students. A charged oil drop remains stationary. Charged oil drop remains stationary when situated between two parallel metal plates separated by 0.05 meter and potential difference of 2000 volt is applied. Find the charge on the drop if its mass is 1.5 into 10 power minus 14 kgs. So, a charged oil drop. There are two parallel metal plates. I say this is positively charged, negatively charged. And an oil drop is held stationary between these two parallel metal plates. Stationary andrenu, I have already told in this session, equilibrium, balance. When is equilibrium created? When two forces balance each other. When two forces equate each other. So here, the force acting on this oil drop due to the electric field should be equal to the weight of the oil drop. Therefore, the force due to the electric field is equal to the weight of the oil drop. What is the expression for force? Yes, this is Q into E. Weight is M into G. E is not mentioned, but potential is given, distance is given. So we know E is nothing but V divided by D. Electric intensity in terms of electric potential, V divided by D, M into G. So Q, so this is 2000. What is the distance between the plates? 0.05 meter or 5 into 10 power minus 2. Mass is given 1.5 into 10 power minus 14. G I take to be 10. So this is 3.675 into 10 power minus 18 coulomb. So this is the charge on the oil drop. The next one, students. This is a slight assignment for you all. An electron is accelerated through a potential difference of 45.5 volt. Applied potential is given. What is the velocity acquired by it? Which means here, we have already used this concept. Gain in kinetic energy is loss of potential energy. So half mv square is v into q. We have to calculate the velocity. So v is root of 2 vq divided by m. So root of 2 into 45.5 charge of the electron, mass 9 into 10 power minus 31. So on simplification, this is 4 into 10 power 6 meter per second. So this will be the velocity. So I have solved problems from electric potential in today's class. In next session, I will be starting up with electric fields and charges. Until then, have a nice time. Thank you.